So just to let you know, I am recording this, so if you have anything you want to say and you don't want to be on the recording, just send me a chat message and I'll get to it. But today we are learning the analysis of structures, and we are going to be solving truss problems. So these problems, we're going to learn one method. It's called the method of joints. The method of joints. That is what we're going to be doing. And we're only doing one type of problem. So both quizzes are going to be the same thing, the same problem. And the test will probably have 2 problems on it. So you will have to be, and it's going to take, it usually takes a little while. So please make sure that you are prepared for that test, because if you don't get this stuff, you gotta keep after it, because you have to be very neat and you can't make any mistakes when you're doing these problems at any point, because they all kind of build on each other. So with a truss, right, in a truss system, we really have what it's going to be. I'll just sketch one out here real quick. You have members and joints. So a joint is where it comes together. So this here, this is a joint. That is where the members come together at a joint. And these are all members. And we characterize them by their joints. So this would be member AB. And the key is members act on joints. Members act on joints. So if our member here looks like this member is compressing. It's pushing inward on the joint. And what happens on one side of the member has to happen on the other side of the member. That's Newton's third law, action, reaction. So you can have compression, which I spelled wrong, and then you can have a joint that looks like this, and you can see that member is pulling on the joint. That is tension. So whenever you're finding your members have to be designated compression or tension. That's one of the keys. Now, we're going to have external forces acting on our member, right? We'll have these external forces like we did last time in chapter 4. And these external forces only are used at the joint. So these green ones would be external forces, right? We can have all kinds of external forces on here. And these act at the joints. So those are the 3 or 4 key things. Members act on joints. External forces in green are what cause there to be forces in the members. Members are tension or compression. The tension pulls on the joint, and the compression pushes on the joint. And when you're solving these problems, we have to find all of the external forces to begin with. So it's just a big, giant, non-concurrent force system. So what we're going to do is just open up our books, and we're just going to try some of these problems and see how far we get here in our time together. Because that is the best way to do it, is just to work problems. So I'm going to do problem 5.2 first on page 105 if you don't have the international version. And it looks a little something like this. Now, this is really going to be hard for me because I don't know how I'm going to do all this on one page. Oops, I don't know. It looks a little bit more like this. And we have joints A, B, C. Those are, oh, that's not a, there's no force here, sorry. That's just a triangle. That was just giving us a distance. So our distances are from here to here and here to here. This is 8 foot. This is 10 foot. Or is that 16? Sorry, that's 16 foot. And then we have our vertical distance, which is 10 foot. You can see at A, we have a pin. So a pin is going to give us two forces, AX and AY. So we'll have AY and we'll have AX. And then over at C, we have a roller. We'll call that C. And we have some external forces here. We have 10 kips coming down here. And we have 5 kips here. Is everybody on the same page as me? Now, quick question. Whoever gets this is just going to be my #1 student today. What's wrong with this picture? Can you see anything wrong right now with this picture?
It's squiggly.
Come on. Don't critique the drawing in itself. The actual force is acting on the picture. It's the best I can do here. Any of the forces look weird to you or look like they should be different? Just looking at it.
Is there anything to go against the 5 kips in AX?
Hey, good. Who said that? You
Luke.
don't have to say your name because it's if you don't want to because we're on a recording. But
Oh, it's fine.
who was it?
Me?
Oh, good. I can see you highlighted in green. Good job. You're right. There's nothing going against the 5. Remember, we learned this last chapter. So that tells me what? AX has to be going left. AX has to be going that way. Because our first goal, goal #1, is to find all external forces. And you can see we got ourselves a big non-concurrent force system here, right? So all of these trusses, the first thing you're going to do is find all your external forces, and it's going to be a non-concurrent force system in equilibrium. And you architects know these trusses have to be in equilibrium, right? You don't want your truss moving. So we're going to have our 3 equations. The first thing you want to do is use your 3 equations and set them equal to 0. Just like we did last chapter. So we're going to go ahead and find these 3 forces. AX is the easiest. Sum of the forces in the X equals 0. AX equals 5 kips. And we know it has to be going left because the 5 kips is going to the right. That's the first one. Now we have to do our moments. Sum of the moments about A equals 0. So C is times 24. That's going to be positive. Counterclockwise rotation. The other 2 are negative. So we have -10 times 8 and -5 times 10. Set that equal to 0 to solve for C. So C then equals 80 plus 50 divided by 24. 5.42. Any questions there? And then our final step is to find, well, always write, you got to write these in as you go because you'll just lose your minds. And then sum of the forces in the Y equals 0. So AY plus 5.42 minus 10 equals 0. AY equals 4.58 kips. Follow me so far. Anybody need anything clarified there? That's the review from last chapter. Anybody? This is This is your big opportunity before I move to step 2, because I got to erase all this. All right, so that's all done. Hopefully you took good notes. So I got to erase everything here. It's going to take me a second, because the reason I'm doing that is because I want to see this picture the whole time. So if I was like in class and not online, I would use the whiteboard and I would leave this picture up the whole time because I want to fill it in as I go, which is going to be crazy when I get to the bigger ones, but I only have this small whiteboard to work with. So that's step 1, is to find your outside forces. Step 2 is to do the method of joints at each joint. So the way you do that is you just isolate the joint. So you say joint A. And you draw joint A. And you draw all the forces acting at joint A. So we have 5 going this way. We have 4.858 coming up. We have AB. And we have AC. Now, you got to do a little thinking and think to yourself based on what you know. Now, all of these are concurrent systems in equilibrium. So all your joints, you're going to have the sum of the forces in the x equals 0 and the sum of the forces in the y equals 0 for all these joints that we do. Highlight that in blue so we don't lose it there with my squiggly lines. So we're on joint A. Look at AB. AB, you can see it's either going to be, we got 2 choices, first quadrant or third quadrant, right? It can be one of those 2 forces. It can either be tension or it can be compression. Think to yourself, you don't have to say anything, think to yourself which one you think it needs to be to make that joint in equilibrium. Hopefully you chose compression, right? It has to be the compression because the x component of AB, oh no, I had the eraser on. The x component of AB is going to go this way, but the y component is going to go that way. ABY has to equal 4.58 for it to be in equilibrium. Do you see that? So if AB is going left and 5 is going left, AC has to be tension to cause equilibrium. So what we're trying to do here is get all these forces working to make the sum of the forces in the x equals 0 and the sum of the forces in the y equals 0. And some of the stuff you can do without even any math. Now, before we do anything, we're going to have to find this angle here, right? So our triangle is 8 by 10. So to find that angle, tan theta equals 10 over 8. (51.34 degrees). And I might as well get this one while I'm in here. That one is 16 over 10. So that's 58 degrees. Let me erase that. I'm going to need that room. All right, so now, normally I don't label the triangles with the angles just because on a bigger truss, it's going to be hard. I usually leave it off to the side, but this is our first one together. You'll see we don't need B's angle. So here we are. We're back on joint A. So let's set up our 2 equations. We have the sum of the forces in the x equals 0 and the sum of the forces in the y equals 0. Well, we have to do the y first because we have ABY. We know this angle here is 51.34 degrees. So we can say AB sine of 51.34 equals 4.58. And then we can solve that for AB. 5.87. 5.87 kips, and we know it's compression. That's our first answer. We solved for member AB. Now what I like to do is go up here and write it down, because on the bigger trusses, we're going to need it later. So you write 5.87, and you put the arrows on there to show you how it's acting in the member. Now in the X direction, we have three forces. We have this 5 kips, right? We have ABX, and we have AC. We have those three forces. So here we have AC minus 5 minus AB cosine of 51.34 equals 0. AC equals 5 plus 5.87 cosine of 51.34.
Okay, I found this on the web for AC equals 5.
Siri's got the answer. 8.66. And we know that's tension from our earlier study, or our earlier analysis. So I got AC. I'll write that in. Does everybody have any questions on what I did there? All right, I got to erase this. I'll start over here in case you're behind. We'll leave the sum of the forces in the X and the Y there because we'll need that again. All right, so we did joint A. Now we're going to do joint C. We could do joint B if we want to, but we don't really need to. Joint C will be easier. So we do it again. We draw it. 5.42. We know that this is going to the left, 8.66. And we have BC. Think to yourself, is BC going to be compression? Is it going to be in the fourth quadrant, or is it going to be tension in the second quadrant? Everybody had a time to think? Well, it's got to have its X component cancel out that, and its Y component has to cancel out 5.42. So BC has to be compression. We know this angle here is 58 degrees. And now we can pick either equation. It doesn't matter. I'll go Y just because my pen is already there. So 5.42 minus BC sine of 58 equals 0. BC equals 6.39. And that is compression, right? And we solved our first truss. And 6.39 cosine of 58 better equal 8.66, or else we screwed up. It's not looking good, is it? $10.8? No, that looks about right. What about 16.10? Did I put that in the calculator wrong? Yes, that's my problem. There's 58. That's not the right angle. Nobody caught that? It's 16.10. I did 10 over 16. It's actually a 32-degree angle. Boom. Got my error. This should be 32 degrees. That should be 32 degrees. So that makes this 32. And that makes this number here 5.42 divided by the sine of 32, 10.22. 10.22 kips. So then we come up here. Now we're right. See, the nice thing about these problems, you always check yourself. 10.22 kips. Scarlett, you should have picked up on that error. Somebody's got to be watching over me at all times. So 10.22 cosine of 58 is 5.42. That's still
10.22
that's
sine of 32.
33. Yeah, 30. See, I got to have somebody watching my back. It's not as easy as you would think. Boom. Now we got it. 8.66 equals 8.66. Yay. Whew. All right. Any questions on that? Let's try another one. What I'm going to do is get you a problem. We're going to do number 5.5 at the bottom. I can only do so many of these in a period because I like to let you guys try them and it takes a while. So this is what 5.5 looks like. Luckily they give us the angle so I can't screw that up this time. So we got 300 pounds going this way. We got 600 pounds going this way. I don't want it to be that big. I'll never have room for anything else. We got our joints. So AX has to be going left. AY is going up. C is here. We know these angles are 30 degrees. And we want to find our missing joints, AB, BC, AD, and CD. So that's our goal. We want to find AB. We want to find BD, CD, and AD. Those are our goals. So the first thing we're going to do is find our external forces, right? So sum of the forces in the X equals 0. AX equals 300 pounds. That's easy. So I fill that in. Now I do the moments about A. Set that equal to 0. So I didn't put my distances in here because I forgot. 12 foot, 12 foot, and they don't give us that because they gave us the 30 degrees. They just want to make us sweat it. We're going to need that vertical distance there of 30 if this is 12. So tan of 30 equals y over 12. Y equals 12 tan of 30. 6.93. So this distance here is 6.93 feet. And we need that for the moments. That's why I went and found that. So 300 and 600 are both going negative. So C is going positive. So C times 24 minus 300 times 6.93 minus 600 times 12 equals 0.
6.39, I thought.
Thank you, 6.39. So C equals $379.88. $379.88. And then we can do the sum of the forces into y, set those equal to 0. So that's A plus 379.88 minus 600 equals 0. $220.12. This is 6.93. I wrote it down wrong here. Son of a gun. Oh, good thing I double checked that too. Not on my A game tonight. Sorry, guys. It's going to screw all this up. $386.63. Better to get your errors out now than in the end. 386.63. And so this is 213.37. All right, I think we're on track now. Hopefully you're not thoroughly confused and you're following me, even though my A game is not intact here. First thing we're going to do, we're going to start at A and do the method of joints. Now, one thing you can notice is that if we come up here to like B, notice I have 1, 2, 3 unknowns. You can't solve a joint with 3 unknowns. It has to have 2 or less. So we'll always usually start where we know most of them. So we'll start at A. Just going over here, join A. And I'm going to take a little breather here and see if you guys can draw join A. Just draw it. You don't have to solve it out. We'll do that together. All right, so that's what it should look like. And we can see the AB has to be in the third quadrant because the y component of AB has to equal 213.37. So then we have an x component of AB. And just like last time, this means AD has to be going to the right. So it's very similar to our last problem to start. Now we'll do the math. I'll do the y first. We have to because of this AB situation. So AB cosine 30 negative minus 300 plus AD. Oh man, I'm doing the x. Sorry about that. 213.37 minus AB sine of 30 equals 0. AB equals 426.75. So we can write that in. Then we can do the x direction for AD. AD minus 300 minus 426.75 cosine 30 equals 0. $669.56. And that's tension. AB is compression, tension. We can write it up here in our little chart. Any questions on that? Anybody have any questions here? All right, I just double checked the solution. It looks like we did it right. So that makes me happy. Now I'm going to do D with you, and then I'm going to give you guys one to do on your own. Joint D. Joint D is so easy. That's why I'm doing it. 600, 669.56. We got BD, and we got CD. Well, it's easy, right? They have to be the opposites. This has to be 669.56. And this has to be the opposite of that to cancel it out. So that has to be 600. So that's 600 tension, and CD is 669.56 in tension. And the final one, which I failed to write, is BC. So what I want you guys to do is to do BC, the whole thing. Draw it out and find what BC is equal to. We're on joint C here. So I'll draw it out. We got one force up, 386.63. We got BC this way. And we got 669.56. We can see, just like before, it's got to be in the fourth quadrant. We know it's at 30 degrees. So sum of the forces in the Y equal 386 equals 0. So BC sine of 30 equals 386.63. $773.26. And that's compression. And we did our problem. That's everything. Any questions there? Anybody have any questions there? Nobody? Everybody got it right? All right. Let's see what you're made of out there. Let's try. What time is it? We got 20 minutes or so. Let's get one started for you. One of the homework problems just started to go in here and see where it takes us. Let's do 4. 5, 4. Now, if you see a 0 in anything, you can have a 0. That just means that with that combination of support, there's no force in that member with the outside forces acting that way. So if you see a 0, don't freak out. They can have zeros. And when you do 5, 6 for your homework, you'll see that it's symmetrical. So you really only have to solve one half of it. The other half's exactly the same. Anyway, here we are at 5, 4. It looks a little something like this. I'm not sure if there's a specific name to this type of truss. And we only have vertical forces, so A and C here. We're not going to have any X support. Remember, this is just a support system. So why don't you all, I'll put the distances in. Find the outside forces. That's the review. All right, so for joint A, we found our outside forces here for joint A. We know the angle is 56.31. So we got to draw it out. Now that's up, so that means AB has to be in the third quadrant, or AE, I'm sorry, and AB has to be to the right to make that all cancel out. So to do this, we say the sum of the forces in the X equals 0. And the sum of the forces in the Y equals 0. So AE, right, AE is going to have an X component and a Y component. And we know our angle here is 56.31. So AE sine of 56.31 equals 66.25. $79.62. And that is going to be compression. And then in the X direction, AB minus 79.62 cosine of 56.31 equals 0. $44.17 kilonewtons, and that's tension. So we have AB, it's 44.17, and AE is compression, and it's 79.62. Now you can't go to joint B next. Remember, we said you have to have 2 unknowns or less. So you can either go to C or up to E. Let's do joint E next. This will be the last one we do. I'm going to give you about 5 minutes to do this. Joint E is the one I want you to do. So do joint E, and then we will be done. Mickey, you made it? Mickey? Is that you? Mickey? Who else was not here in the beginning? Chase? Is Chase here? Is anybody here? Am I muted?
I'm here. Sorry, I was muted.
Chase, did you make it? I don't see you. All right, we're doing joint E, everybody. Joint E. All right, we're running out of time here, so I'm going to start this up. I want yellow. Can't see that too good. Now this one's going to be a little harder to know what's going on because of that 80 kilonewtons. Now we know DE's got to go left to cancel out the 79.62. We know this angle, which I totally erased. Is 56.31. And we can see 80 is going to be bigger than that Y component. So BE is going to have to go up to help that. That's my guess. I could be wrong. But we'll do our best. Sum of the forces in the X equals 0. We can do the X first this time. 79.62 cosine of 56.31 equals DE. DE equals 44.17. Notice it's the same as down below. DE and that are the same because that AE is interacting with both those forces, and that's compression. See, these two things are the same because the only X acting on both of them at their joints are the 79.62. Just a fun little physics thing for you. And then sum of the forces into Y equals 0. We're going to have BE plus 79.62 sine of 56.31 minus 80 equals 0. BE equals 13.75 kilonewtons, and that is compression as well. And then we just fill out the rest of the truss, and that's what you'll do for homework. So that is the method of joints. We'll do the same thing on Wednesday evening. I'll go through the method of joints again, talk about just do more problems, answer any questions that you have.